Well, let me begin by saying what a pleasure it is to be here with an intellectual hero of mine from my youth. His book, The Selfish Gene, was kind of an epiphany for me. And it's a heady experience to be here with Richard and to engage in a conversation with him about evolution in this wonderful venue. So let me put the ball in play. The Supreme Court Justice Potter Stewart once famously remarked that although he couldn't define pornography, he would know it when he saw it. My question to you, Richard, is although we may not be able to define what we mean by life, will we recognize it when we see it?
This question arises especially if we're thinking about life on other worlds. How would we know if we'd got life? I think what we have to say is that it is organized complexity in the direction of what apparent purpose or apparent design. By complexity, I mean statistical improbability. Everything is statistically improbable in one sense, but if it's statistically improbable in the direction of apparent design for doing something useful for some entity, then we have life. Of course, it could be an artifact. It could be a car or a plane or something like that, but quite clearly is designed for that purpose. But that is evidence of life. If you found something like a plane on a planet, you would say that may not be alive, but life is on this planet.
Is it possible that something like incipient life, that could be potentially extremely difficult to disentangle?
Yes, I mean something like bacterial life, and that you would have to be a chemist to decipher. But I think probably most people are interested in more complicated kinds of life, the sort of life that we know with big bodies or even intelligence.
Does life anywhere, in any form, anywhere in the universe, is Darwinism an essential part?
I would put my shirt on a yes answer to that, yes. The only viable alternative that's been suggested so far in the history of science is Lamarckism, the inheritance of acquired characteristics coupled with the principle of use and disuse. The more you use a bit of yourself, the bigger it gets, and you pass it on to your children. It's often been said that the only thing wrong with the Lamarckian theory is that acquired characteristics are not inherited. I have published, I think there's no time, we've been asked to stick to 20 minutes, by the way, which is difficult. Even if acquired characteristics were inherited, then I contend very strongly that the Lamarckian theory is still not a big enough theory, not a good enough theory, not a powerful enough theory to explain life. And I think that's a universal principle. Lamarckism simply won't do. And I published it, I think it's the last chapter of The Blind Watchmaker, why that is.
Would you say that life, as it is on Earth, is essentially carbon-based? Is that a universal attribute of life?
I'm not enough of a chemist to be sure of that. So as a matter of fact, at the previous Starmus, at Starmus 2, I put that very question to the lamented Harry Kroto. And Harry was very, very positive about this. It's got to be carbon. Only carbon has the necessary properties to, that were link arms in the kind of tinker toy fashion that you need in order to do biochemistry.
I would put in as an astrophysicist, it's also an order of magnitude more abundant than, say, silicon, which is its...
Well, silicon is the other thing that's occasionally
tetravalent
suggested.
cousin,
yes.
Yeah.
I mean, in another sense, I suppose, silicon could evolve by Darwinian means in the sense of evolution in computers, and that's interesting. And it could well be that the life form we find on a planet has left its carbon dawn behind and has turned into a purely silicon form of life, and is properly evolving in silico. That is a possibility.
Possibility. Doesn't have quite, from what I understand, the same versatility as carbon. It's tetravalent.
No, that's right. I mean, it
has a problem with double bonds.
Not for biochemistry, but if we're talking about computers. I mean, evolving...
Semiconductors.
Evolving, yes, exactly, yeah.
Understood. So I think we would agree that whatever form life takes, genetics will have to be part of it. We need some kind of information storage and replication thereof.
Yes, I mean, the essence of Darwinism is replication. It's the passing through generations of coded information which takes steps and which is selected to take steps to preserve itself, and ultimately to do so via bodies, via what we call phenotypes. So there's got to be a replicator. That is the sine qua non of Darwinism. On this planet, it happens to be DNA. I think there's absolutely no reason to expect that it would be DNA on any other planet. It could be some other kind of molecule. But it's got to have the same high fidelity as DNA. This is a very important principle of Darwinism, that mutation rates have got to be very low. It's got to be extremely high phi replicator. DNA achieves that, especially because of proofreading. So whatever else it would be, it would have to be extremely high fidelity. And I think that means it has to be digital, by the way, rather than analog. I think in order to get enough high fidelity, it's got to be digital. As to whether it would have to be a one-dimensional code, as DNA is, that's not obvious to me. I don't see why it shouldn't be a two-dimensional matrix, which could be read with the same kind of high fidelity.
So when you say two-dimensional matrix, you're not talking simply about storage of a one-dimensional object being curled back on itself. You mean the information essentially has two indices, a row and a column.
That's right. You've got an x-axis and a y-axis, but I don't think it could be three-dimensional, because a three-dimensional code, you can't read the inside. It's inaccessible. That's essentially why I think protein could never be the replicating molecule. Protein could never be the genetic molecule, because protein is coiled up in three-dimensional way.
As is DNA, of course.
Well, of course, as DNA, but DNA
so
uncoils very easily.
Yeah. It's true, actually. In one dimension, the combinatoric possibilities are already, to me, it seems so vast.
Yes.
That it's not as though there's an advantage.
Even if it was DNA, of course, there's no reason to suppose that the code would be the same. It wouldn't have to be
no, absolutely.
Yeah.
That presumably is an accident. It's not even the same from one organelle to another, from mitochondrial DNA.
Not quite, no. It's near enough the same that we are sure that life, or all present life, has one common ancestor.
Now, we know that there must be, on Earth, complex organisms are constructed in such a way that they began with cells and then self-assembled, so that organisms consist of many, many billions of cells, all particularly differentiated from one task to another.
Yes,
Do you see this as a universal attribute?
Well, that's interesting, isn't it? Because, once you get into big bodies, once the replicators have started building for themselves what I call survival machines, the way we do it on this planet is we have billions of cells, and each cell has a copy of the entire genome. On the face of it, that's a very uneconomical way of doing it. You might think that a big body could simply have one copy of the replicating material. So, but I think it probably depends upon the system of embryology. The kind of embryology that we have depends upon going to a bottleneck in every generation, and then the cells divide and divide and divide again and exponentially increase in numbers and carry the genes with them for each, as you say, differentiation of the cells.
Right, and selectively turn on or not,
and
depending
selectively
upon
turn on
whether they
or
want to be in the liver or the brain.
Exactly, yes. So it's a little hard to imagine an embryology that didn't work like that, but that just may be a limitation of our imagination. I think some of the other things that I've said are not. I think this conjecture that it's got to be Darwinian is better than just a lack of imagination.
Richard, do you think, is there a concept of convergent evolution? There is, of course, on the Earth. We see marsupials, we see mammals, displaying extremely similar phenotypes. Is that something that you would extend to exoplanets?
I would certainly expect that, yes. I mean, we're now getting into details which are I mean, things like, would you expect them to have actually bodies and
Eyes,
legs
ears,
and eyes and ears
wings.
and wings, yes. Wheels, indeed. I think that one of the important principles, and Jill Tarter actually referred to this in her conversation with Neil Tyson, one of the important driving forces of evolution on this planet, and I would expect it to be the same in any other place where there's life, is the arms race. The fact that life is not merely surviving in the inanimate environment, it's surviving in an environment that consists of hostile entities which are themselves evolving. And therefore, when one side, if we can think of predators and prey or parasites and hosts, that kind of thing, when one side advances in evolution, the other side has to advance to keep up. And so you get an advancement in the technology of the life form, the limbs, the eyes, the ears, the claws, the teeth, whatever it is. But they don't actually get any better at doing their job because the other side of the arms race is also improving. And so there's a kind of it's kind of standoff, but what it leads to is the production of these prodigiously complicated, beautifully designed entities like eyes and ears. These are the product of evolutionary arms races. And I would expect that to be true anywhere where there's life. As to whether you'd expect to see eyes, well, that would depend on perhaps the local conditions. If the planet we're talking about is perpetually shrouded in thick fog, so that eyes would be no use, then I'd expect to see the evolution of some other guidance system, such as echolocation. But these we're getting into sort of details now, which are indeed fascinating.
Presumably, the very concept of a complex nervous organization in the form of a brain is the product of an arms race.
Exactly. I mean, I think that electronics, which we can call brains electronics, was one of the early devices which arms races produced and has perfected and increased in size. And so the very large nervous systems, very large brains which mammals have, especially humans have, has got to be the product of an arms race. A guidance system to take in information, process information, control the motor output, remember what happened in the past, benefit from experience, simulate in imagination, possible future, alternative futures, and so on.
And where do you see language fitting in?
Language is unique on this planet. Plenty of animals, of course, communicate with sound, but only humans have grammatical language. Only humans have hierarchically recursive, self-embedded language, such that you can generate an infinite number of sentences and convey meaning, complex meaning, which I think only humans can do. So because that's only evolved once, of course there has to be a first time, because it's only evolved once, it's not a thing I'd necessarily predict. I actually wonder whether syntactic, hierarchical, recursive grammar might have started out not for communication at all, not for language, but possibly as a means of controlling behavior. It could be that organizing your life, organizing a hunt, say, if you're a predator, organizing stalking a mate or something of that sort. I could imagine that would be best done by the same sort of hierarchical principles as we see in Chomskyan grammar.
Right. And presumably, at least what we're used to seeing on Earth, there's a single gene which seems to have turned on about Neanderthal time, this FOXP2 gene, which leads one to wonder how much of a quirk this is.
Well, that's very interesting. I mean, the FOXP2 gene is one that all mammals have it, but it exists in mutated form in humans, in the sense that humans, including Neanderthals, are the only apes, only monkeys, only primates, only mammals that have this particular mutated form of FOXP2. All the other great apes have the normal type, the normal mammalian type. And there are some mutant humans who have reverted to the non-human form of FOXP2, and they can't talk. And so because this is a conspicuous example of a gene which is different in humans, including Neanderthals, from chimpanzees, etc., and it seems to, and when humans revert to the chimpanzee form, they can't talk. That is quite suggestive. And it raises the fascinating possibility that language might have come about as a result of a single mutation which made it possible. And that goes right against my grain. Are we being winked at by the chairman? I can't see.
Are we doing that time?
It's no wonder we've been overrunning because we can't see the... Yes, okay, there we are. Did you say 5 minutes? Yeah, okay, fine. It normally would be anathema to me to suggest that any major complex evolutionary change could take place in one giant step. It goes right against the grain. But maybe this is an example. Maybe this is... I mean, it wouldn't have... One wonders who the first mutant could talk to. But...
It would have to be a family dinner table.
Would be a family,
conversation,
that's right, yeah.
And presumably that's been a critical step in understanding sort of, well, in the development of intelligence itself.
I mean, it seems to me absolutely critical.
Explosive.
I mean, I think that the whole of cultural evolution, the whole of technology, everything really that makes human life so conspicuously and magnificently different from the rest of the animal kingdom, my view is that it stems from language.
All right, since we're running short on time, let me get to the punchline question. What is your gut feeling, Richard, about the possibility, A, of life elsewhere in the universe? I could have begun with this question, but I prefer to save it as the denouement. And B, intelligent life elsewhere in the universe.
You know what Carl Sagan said?
You,
you know what Carl Sagan said when he was asked that question? He said, "But I try not to think with my gut." Okay, I will think with my gut. I mean, the answer has to stem from the prodigiously large number of stars that we have in the galaxy, well, in the universe, but even in the galaxy. What does he say, 10 to the 11?
10 to the 11.
Yeah, okay.
That used to be more prodigious than it is right now. That's smaller than the size of the U.S. economy or most of the economy.
Yes, okay. So it does seem to me to be very likely that there is both life and intelligent life in the galaxy, let alone in the universe. However, one has to say that since we only have one sample, if it were true that we are the only life form in the universe, let's say, and we don't know that it's not, if that were true, then it would have the consequence, if you want to believe that, then you would have to say that the origin of life, the chemical event that gave rise to the first replicator molecule for about 4 billion years ago, had to be a quite stupendously improbable event. Otherwise, the universe would be crawling with life, which I think it is. But if you want to believe that it isn't, if you want to believe that we're unique, then you're committed to the view that the origin of life was absurdly improbable, such that chemists are totally wasting their time speculating about how it might have happened, because we're not looking for a plausible theory now for the origin of life. We're looking for a mega implausible theory in order to conform with your belief that life on this planet is unique. If it is the only life form in the universe, then by the anthropic argument, it's got to be here. This is the planet where it happens. So we cannot rule out the possibility. And you can make the same argument for intelligent life, which is obviously much less likely than life. But even so, if you think about the sheer number of available planets, it could be only as few as, I don't know, 1 in a trillion planets let me say as many as 1 in a trillion, because a trillion is a very small
Richard,
number.
1 in a trillion may not do it. Not in the galaxy. Yeah.
Oh, okay, one in a billion then. Yeah, you're right, my mistake. 1 in a billion. But even if it was 1 in a billion, then these islands of life, this cosmic Polynesia might be, the islands of life might be so spaced out that no one island would ever meet, have a conversation with any other. By the way, if we do ever have a conversation, it'll certainly be by radio or some other form of electromagnetic radiation. We're not going to be visited.
All right, I think on that note, I can see our chairman is
I think
coming.
we're the only ones who've kept to time.
Yes, good. Thank you, Richard.
Thank you, Richard and Stephen.